In this video, I am going to explain epicyclic gate train problem 2. The last video I explained a simple problem. Now let us see that for a reverted gate train how we can solve the epicycle problems. We will see in this video. Let us first see the problem. In a reverted epicyclic gate train, the arm A carries two gears B and C and a compound gear DE. The gear B meshes with gear E and the gear C meshes with gear D. The number of teeth on gears B, C and D are 75, 30 and 90 respectively. Find the speed and direction of gear C when gear B is fixed and the arm A makes 150 rpm clockwise. Now see that this is a reverted gate train. So the gear C is messing with gear D and gear B is messing with gear E, and these gears are connected with arm A. Here gear D and E are compound gate trains. So E is messing with B and D is messing with C. So the gear B and gear C are in the same axis. The given data, the number of teeth of gear B, TB is equal to 75, the number of teeth of gear C, TC is equal to 30, number of teeth of gear D, TD is equal to 90, speed of the gear B, NB is equal to 200 rpm anti-clockwise direction. So to be found, determine speed of gear C and its direction. So we need to find out what is the speed of gear C and its direction. Now let us see the solution. So this problem may be solved by using tabular method. In the last video, I told both algebraic method and tabular method. If anybody wants to know how to solve the problem in algebraic method, please watch the last video. So now in this, the center distance between the two shafts are equal. And also here the dB plus dE is equal to DC plus DD. So what is D? D it tends to pitch circle diameter of the gears B, E, C and D. And the number of teeth is directly proportional to the pitch circle diameter. So it's also equal to TB plus TE is equal to TC plus TD. So from this, the number of teeth of the gear E is unknown, remaining 3 are known. We can find out from this equation, therefore TE is equal to TC plus TD minus TB. So we can determine the number of teeth for gear wheel E, that is 45. So now all the gears number of teeth is known. Now use the tabular method. First prepare a tabular. Okay. So here the step number, condition of motion, speed of gears, elements. In this arm A, D and E are compound gears. Because compound gears are connected to the one shaft, the speeds of the gear D and E are same. So I am keeping only the one column. If you want, you can keep the same column, but values are same. Now you can see the first step, arm fixed and compound gear DE rotates through plus 1 revolution. Here I consider compound gear for given 1 revolution. According to this statement, find out the speeds of the other elements. So arm is 0 and compound gear DE speed is plus 1 and B. So the B is messing with E. So both are rotating opposite directions. So minus TE by TB and C. C is messing with D. So these are also rotating in opposite direction. So negative sign minus TD by TC. So this is the first row. Step number 1. Arm fixed, compound gear DE rotates through plus 1 revolutions. According to this condition of motion, we determine all the speeds of all the elements that is obtained here. Now in the second step, instead of plus 1 revolution, we are giving the plus x revolution. The remaining statement is same. So according to just multiply above elements with x. 0 plus x plus TE by TB x plus TD by TC x. And the third step is add plus 1 plus y revolution to all elements. Plus y revolution to all the elements. So y, x plus y, y minus TE by TB into x, y minus TD by TC into x. Apply the given conditions and determine x and y. Speed of arm A is NA is equal to y is equal to minus 150 rpm. So minus is given here, that is a clockwise direction. We are assuming that anti-clockwise is plus and clockwise is minus 150. Speed of the gear B is 0, therefore NB is equal to 0. So from the table, speed of the gear B is NB is equal to, you have to find out from the table y minus TE by TB into X. Speed of the gear B is NB is equal to minus 150 plus 40 by 75 X is equal to 0. So X is equal to 250 RPM. So speed of the gear C you can find out, that is NC is equal to y minus TD by TC into X. So substitute the data, you can obtain the speed of the gear wheel C is 600 RPM. And here positive is there, so that is in anti-clockwise direction. The direction of gear C is in anti-clockwise direction. So likewise you can solve the problem. Here in tabular method almost all are in the similar way you have to solve the problem. I hope everyone can understand